So thank you again, everybody. This talk is going to be called Quantum Metaphysics. So quantum, the word you usually expect to find in physics. Metaphysics is a word you usually expect to find in philosophy. Part of the message of the talk, as I say, is that these are fields that can and should be collaborating together to investigate topics of common interest. So here's the sort of plan I'm going to be talking through. Firstly, talk a bit about what metaphysics is and whether, in particular, we can do metaphysics using science. So whether science is relevant or can help us find the answers to questions in metaphysics. Metaphysics is often thought of as kind of one of the purest bits of philosophy. So it might be a bit of a surprise to find physics able to help us out or steer our course when we're doing metaphysics. But I think it can. And I'm going to spend most of the talk talking about a particular example of that, a particular example of where I think physics can help us understand philosophical issues, help us answer philosophical questions in ways that we wouldn't have thought to answer them without the physics itself, or wouldn't have answered them as well without the physics. And I'm going to describe a positive project that I've been engaged in for a number of years now, which is a project in the metaphysics of modality, as philosophers say, the theory of possibility, necessity, contingency in particular, the way things could have been otherwise from the way they actually are. And I'm going to suggest a way in which quantum theory, in particular, many worlds quantum theory, Everettian quantum theory, as philosophers of physics will often say, and use that many worlds approach to quantum mechanics as a way to understand the philosophy of contingency in a new and unexpected sort of way. That's the plan. So first section is what is metaphysics and can science help with it? So I think it can. So defining metaphysics is a bit of a difficult and unrewarding business. It means many things to many people. There's probably one or two people that have come here expecting metaphysics to be about the kind of things you might find in a metaphysics section in a bookshop, especially in America, maybe, where it's about the occult and crystals and telepathy and those sorts of things. That's not the kind of metaphysics I'm going to be talking about, I'm afraid. The kind of metaphysics I'm talking about is the kind of metaphysics which is a sub-branch of philosophy, which is the philosophy of reality, basically. And in particular, it's the philosophy of the most general aspects of reality. So I've got a few classic metaphysical questions thrown up on this slide. What exists? What is everything made of? What's time? How does that work? How does it flow? What's a person? What makes somebody the same person from now across time? And what makes an action good or the right thing to do, or what makes something beautiful? These sorts of questions are all metaphysical questions. And especially that last case where there's a link to kind of ethics or aesthetics kind of highlights one aspect of metaphysics, which is that you can apply it to almost anything. For anything real, or you think might be real, you can ask about what it's like. You can ask these very general questions about it. So I think metaphysics is great. I think these questions are super interesting. I think they are non-trivial. I think there are interesting things you can say to answer them. But not everybody likes metaphysics as much as I do. It's no surprise. It's been viewed with suspicion for a long time. It's viewed with suspicion now. Lots of scientists you can find on Twitter dissing metaphysics in one form or another. What they take to be metaphysics. But the modern, as in the modern era, kind of anti-metaphysics approach goes back to Hume, kind of prominently, at least. And so I just got a few kind of quotes from people about the relation between science and metaphysics. So I won't dwell on these for too long, but I just think the Hume is too good to not display, especially in Edinburgh. And so he's saying metaphysics is a waste of time. He says, if we take in our hand any volume of divinity or school metaphysics, that is metaphysics as it was done at the kind of time by the scholastic philosophers, he says, let us ask, does it contain any abstract reasoning concerning quantity or number? Is it maths or logic? No. Does it contain any experimental reasoning concerning matter of fact and existence? Does it tell you what you kind of found out in the world? No, there isn't anything like that in the metaphysics books. He says, commit it then to the flames, for it can contain nothing but sophistry and illusion. This is a lovely turn of phrase. Hume is one of the greatest writers in the history of philosophy, and he thinks that this huge field of metaphysics, all these sorts of questions here, if they can't be answered by kind of pure maths and logic, or by going out and checking right out there in the world, then he thinks these are bad questions, and the books about them are worthless. They're full of sophistry, arguments that appear to be good, but in fact are worthless, and illusions. Like, you think you've got a good reason for believing something, in fact you don't. He thinks metaphysics is actively pernicious. It's not just that it adds nothing to human knowledge, it actually does damage by leading us to think that it can give us substantial knowledge when it can't. So Hume wasn't keen on metaphysics, and this I'm going to cut the history, but this anti-metaphysical attitude continued and intensified through into the early 20th century. Logical positivism, many of you will have heard of, hated metaphysics and gave basically souped up versions of this kind of Humean anti-metaphysics critique. So fast forwarding to the middle of the 20th century, we have this character Quine, Willard van Ormond Quine, and he's often credited, accurately or not, with rehabilitating metaphysics, kind of making people, making metaphysics okay to do again, like kind of acceptable as an academic pursuit. And again, cutting a lot of details, one way that Quine rehabilitates metaphysics is by emphasizing that these questions aren't fancy, complicated, requiring like deep theoretical vocabulary that nobody understands. They can be put in an incredibly simple way. There's the ontological problem, long word, ontological, but all it means is, what is there? And simple answer, everything. Everybody will agree that everything exists, everything that there is exists. Not using the word exists, but everything there is. And the question is about a particular purported thing, does that exist? There remains room for disagreement over cases. And this may look kind of a benign observation, but over time, this way of thinking, that metaphysical questions are just ordinary questions posed using ordinary vocabulary that we answer in the way we answer ordinary questions, to the best of our ability, kind of using our understanding of that vocabulary and what we know about the way things are. So metaphysics has been trundling on more successfully in philosophy in recent years. But a version of the anti-metaphysics critique from within philosophy that has come up again and again over since really the turn of the century in particular. So in the 21st century, it's a slightly different kind of anti-metaphysics critique, not the kind of universal one of Hume and the positivists, but the idea that metaphysics, at least as people currently do it, as people, me and my colleagues working in philosophy departments do metaphysics, that we're kind of doing it badly because we're not taking account of science. So I try to take account of science in my work. I don't necessarily always get the science right or like interpret it in the right way philosophically, but that's what the aim is. But a lot of metaphysicians don't really think about science at all. And you can put the critique in a kind of relatively polite way, as Katherine Hawley does in this really nice paper, kind of asking to what extent science can answer metaphysical questions from 2006. And again, like the kind of Quine observation, it's almost kind of it's hard to deny that if we're going to have beliefs about metaphysical topics, they should be empirically adequate. That is, they shouldn't conflict with the evidence in front of us. And contemporary science is our best guide to empirical adequacy. That is, it's our best guide to telling us whether what the evidence in front of us says, and hence to judging whether metaphysics is at risk of conflicting with that. This looks kind of so straightforward that it's kind of hard to think how you could deny it. People do. You can put the same kind of critique in a much more vigorous, you could say, kind of polemic or evangelical kind of way. And that happens in this book, Everything Must Go, by James Ladyman and Don Ross, from the same year as that Hawley paper. So there's this kind of tendency to think about how metaphysics should take account of science, whether metaphysics can kind of proceed in isolation from science. And Hawley thinks, at the very least, they should kind of take note of, metaphysics should take note of science and be careful not to apparently contradict science. But Ladyman and Ross go much further. They say metaphysics is only good insofar as it is useful for science. So this is a kind of, you might call this naturalism, but it's anti a huge amount of metaphysics the way it's actually done at the moment in philosophy departments, which, that is to say, without like explicitly starting from science. And they say the only reason for doing metaphysics is to help understand the individual sciences and how they fit together, or rather help understand how the different sciences fit together. The sciences themselves are the best guides to understanding how they work. We don't need philosophy to kind of help get physics right. But we do need philosophy, think Ladyman and Ross, or at least we do need metaphysics in explaining how physics and chemistry, or physics and psychology, or physics and economics relate to each other. So the role is not quite as anti-metaphysics as the Humean logical positivist line, this Ladyman and Ross approach, but they do think that have a very restricted, prescribed role for metaphysics, where all it's doing is helping link the sciences together. It has no kind of like subject matter of its own to investigate. It's just a go between, helping like get the different sciences properly coordinated and linked up. And the last of these people I'm going to quote to kind of set the scene is Craig Callender, who is talking in particular about the kind of metaphysics which is based on intuition. So I don't know if you'll have come across this word in association with philosophy if you're based in physics, but philosophers, the use of the word intuition and intuitively has gone up. You can look in Google Ngrams. People use it more now, especially in scientific papers. And intuition is kind of thought of as a good thing. You want to use your intuition to help you make discoveries in science, and you want to use it in everyday life to make the right decisions. But there's a kind of special purpose role of intuition in philosophy, where people think that intuitions can be evidence for metaphysical claims. And so what Callender is criticizing here is the practice of doing metaphysics by checking your intuitions and seeing what you find intuitively plausible about the world, and then trying to build a theory like that. He thinks that is where science should come in kind of replacing intuitions as a source of evidence about the world. So why does he say that? He says, our intuitions are historically conditioned and possibly unreliable and inconsistent. So we kind of only have these intuitions because of our social history or evolution, contingent reasons. We just happen to have ended up with these intuitions and not others. So the only way to weed out the good from the bad, to work out which of our intuitions are really reliable, is to see what results from a comprehensive theory that seriously attempts to model some or all of the actual world. So here, this is where the science is coming in. He's saying you kind of can't do metaphysics by itself. you have to do it as part of a larger project of trying to understand the whole of reality. And once you're engaged in that, you might try to build a comprehensive theory, in his words, that will include physics and metaphysics. And that's how you'll end up properly taking science into account. So the kind of thing that I'm interested in exploring is this possibility that Callender's describing of metaphysics that is influenced or guided by science. So metaphysics that we don't just kind of pluck out of thin air, metaphysics that isn't coming out of just what we find plausible for whatever reason, or that is coming out of intuitions, or is coming out of language. But kind of metaphysics on this view is a project of finding out about the world in collaboration with natural science, but finding out about aspects of the world that natural science doesn't always or doesn't directly speak to itself. So some of those initial questions we started with, what are things made of and what is time? You can see how physics could be relevant to those questions. Others of them might be harder. Do numbers exist? It's not so clear whether physics is going to be relevant to that, but at least physics is going to be relevant to a good chunk of metaphysics in principle. And so the project of Science Influenced Metaphysics is to explore those bits of metaphysics and make sure that the science we bring in is good science, and the conclusions that we try to draw from the science are the right conclusions. So you might call this, philosophers like to give names for the theories end in isms. So naturalism about metaphysics is a name for this sort of approach. And I'm thinking of it as an epistemic doctrine, a doctrine about what the evidence for metaphysics is. And so naturalism about metaphysics, as I use it, is the idea that things that we find out through doing science are relevant evidence when we're doing metaphysics. They don't completely determine what we should say about metaphysics potentially, but at least we should take the science into account, and it is relevant to these questions. So naturalism just says it's relevant to some metaphysical hypothesis. The radical version would say that truths revealed by natural science are relevant to all metaphysics. And maybe you can get between those two with a kind of holist style epistemology, but I'm not going to dwell on that. That's just an aside. So the way I see this working, the way I see metaphysics as being able to take our best science, in particular today our best physics, into account, is to do that thing that Craig Callender suggests, to take a step back and look for a comprehensive theory that will have some metaphysics in and some science in. So don't try and do the metaphysics by itself, solve that, and then separately do the science by itself, solve that, and then just like put those two together and you're finished. Do them both together, do them in kind of combination, and try and find the best package deal. Because sometimes if you're looking for the best package, you'll need to make tweaks on one side or the other, or on both sides of the thing to get them to fit together into a good package. Sometimes you'll need to make much more extensive tweaks to one side than another to get things to kind of fit well together to a good overall package. But overall, what we're doing is, as Callender says, attempting to build a comprehensive theory of the actual world that will have some physics in it and some metaphysics in it, kind of interlocking, meshing together, and we want the best overall package. So this is all kind of, so far, has metaphysics and physics on a par. But of course, physics does have something that metaphysics or philosophy doesn't have. That is, it has a track record of making predictions. There maybe have been a few predictions made by philosophers or by philosophy. I think the view I'll discuss later makes a certain kind of empirical prediction, which you can ask me about later if you like. But on the whole, philosophy hasn't tried to predict things. and it hasn't led to any new technologies or any new ways to control our lives the way that science, in particular physics, has. So physics has this tremendous predictive and technological track record, and philosophy has nothing like that. Philosophy's never built us any bridges or any iPhones, and it hasn't calculated any atomic spectra to high degrees of accuracy. So if there's going to be a clash between some like proposed part of the physics ingredient of our package and some proposed part of the philosophy ingredient of the package, and all other things are equal, well, the physics has this much better predictive and technological track record, so the physics should be given priority there if there is a direct clash, because the physics has this kind of evidence in its support that the metaphysical claims typically don't. But it won't always be a case of directly clashing. Often it will just be a case of the physics needing supplementing by metaphysics of the right kind to build a really good overall package deal. So you might take our best physics and then try supplementing it with some bits of metaphysics, some theories from metaphysics, and then look at the end result and find what you've got is a bit of a mess. Like the metaphysics just doesn't seem to work well with the physics. You might be able to find some other metaphysical views, theories, definitions, which when you put together with the physics, give you a neat, elegant, unified overall package. And then you should prefer those metaphysical doctrines over the first ones, because the second ones mesh neatly with the physics to give you a powerful and unified overall package, and the first ones didn't. So that's the way I'm imagining evidence being able to be brought to bear on metaphysics, in this kind of indirect way, by finding out which metaphysics works best as a supplement to the physics to give you a package deal which meets our ordinary standards for a good theory, being unified, covering a large scope, not getting anything wrong, those sorts of things. So I'm imagining that we're going to have a collaboration between physics and philosophy, kind of at these questions at the border. But where there's a direct clash, the philosophy will give way to the physics because it doesn't have that direct evidential huge mass of support. But it won't be indispensable because the physics leaves things open. There are various ways of filling out the bare worldview given to us by the equations of physics to a more or less satisfying overall explanatory picture of everything. So I gave you a list of metaphysical questions at the beginning, and how deep the connection between physics and metaphysics is going to depend on which of those metaphysical questions we're addressing. So there's clearly going to be like more relevance of physics to questions about, say, the nature of time than there is relevance of physics to questions, say, about the nature of the beauty of artworks or something like that. The beauty of art is something that is at the very best non-obvious how we could bring physics to bear as evidence on debates about that. But it's much more obvious, or at least in outline obvious, how we would bring physics to bear on questions about time. A classic example is going to be relativity and simultaneity. So whether or not we have to change our view of the nature of time when relativity comes along, but I'll return to that example later. And because how this plays out really depends on which case you're talking about, rather than talking at the level of generality that I've been going at so far for the rest of the talk, I'm going to talk about a more specific example, a case study which I've thought extensively about. I wrote my PhD on this about 15 years ago, and 10-15 years ago, and it's dear to my heart, this topic. This is the metaphysics of objective possibility, what really can happen. is the way I like to think about this. So distinguish what kind of, for all you know, might happen. You know, for all I know, a lot of mathematical necessities are false, but they can't really be false. I just am ignorant about those maths. But the objective possibility that we have in mind is something that is kind of built into reality. It's what really can and can't happen as a result of the nature of things. So amongst the things that can't happen, we might think is that contradictions can't be true. There can't both be and not be a table in the room. Among the things that we think really can happen is like missing the bus that you caught this morning. That really could have happened. I don't suppose many people have been taking many buses right now, but possibility is kind of ingrained throughout our lives, and there's a whole family of notions here. What can happen, what must happen, what probably will happen. So these kinds of objective probability notions, the kind of probabilities that you might attach to quantum decays, or alternatively to the weather forecast, or even to election forecasts. These sorts of probabilities, which were meant to be objective in that they're not just our ignorance, they reflect genuine possibilities in the world. So I'm going to explore the kind of package deal approach that I've described to metaphysics, the project of finding out answers to metaphysical questions by seeing which metaphysical views and theories fit best with our best physics, and working from there to answer the metaphysical questions. I'm going to try and show how that sort of approach can work in the context of real possibility. This metaphysical topic to do with what really can happen. So I'm going to talk about some grades of how seriously you take objective possibility. Or more specifically, these are grades of how seriously you take the idea that science can tell us about objective possibility. So at grade 0, these are philosophers who think that science can tell us nothing at all about objective possibility, but kind of trivially so, because there's no such thing as objective possibility. So there's nothing there for science to tell us about. So these are philosophers who maybe they're more impressed by the power of pure philosophical a priori argument than I am. But they think that we can come up with good philosophical arguments for the view that there's no such thing as real possibility. Possibilities are all in the head. It's all just ignorance. It's all just what we can find ourselves able to believe or not believe. There's no facts in the world about what really can happen or what really can't. And if there's no such thing as objective possibility, then obviously science isn't going to tell us which things are possible and which things aren't. In this objective sense, we don't need physics to do that if there isn't like a substantive fact here. If there's nothing to talk about, then there's nothing for physics to tell us about. This is kind of like the trivial account, but it should be mentioned because some philosophers just don't take any of this stuff seriously. These real possibilities, this distinction between what really can happen and what really can't happen. Although I'm like fully sold on the reality of this distinction between the genuinely possible and the genuinely impossible, not everybody is. So moving on to philosophers that do acknowledge some notion of genuine possibility. We have a large category of philosophers that, broadly speaking, are in some sense rationalist. You might call these philosophers rationalist because they think that reason can tell us is the way of finding out about what's objectively possible. So there's the idea that there is this space of metaphysical possibilities, or what is metaphysically possible, what can happen metaphysically speaking, what kind of the nature of things permits to happen. And that's something these rationalist philosophers think that science can't tell us about. So what science, and especially physics, tells us about, they think, is physical possibility, which is not kind of possibility straightforwardly, possibility simpliciter. It's not this kind of fully general notion of possibility, but it's something like compatibility with the laws of nature. So there's this background space of possibilities, including lots of possibilities where the laws of nature are anything you like. And there's all of these things are genuinely possible. Forces could switch on and off. There could be no forces at all. The universe could consist of nothing but pink elephants dancing. Anything could happen in and of itself, these philosophers think. It's only the laws of physics that rule out these things from being physically possible, even though the pink elephant world is a genuine possibility. It's just not one that our physics allows to happen. And I don't see the appeal, or I don't see the theoretical value of this background space of metaphysical possibilities, which we get to just by imagining what we think could happen, and which science doesn't bear on at all. I don't see what those things could do for us in our theories, why we would even want to think about them if there were any such things. But the point to emphasize here is that the most general sense of possibility, the difference between things that kind of really can happen and things that really can't happen, on this philosophical view, is entirely up to philosophers to investigate. Science is just completely irrelevant to that. Science tells us only about this kind of secondary thing, physical possibility, which is just like a restricted subcategory of real possibility. It's real possibility that also complies with the laws of physics, whatever those happen to be. And so real possibility is this purely a priori philosophical thing, and physics is only relevant to this secondary thing, physical possibility, which isn't fundamental. And I'm not satisfied with that either. That doesn't seem to me to be a suitably robust connection between science and philosophy. I'd like or the metaphysics of modality. I'd like a deeper connection between science and these philosophical questions about possibility and necessity. So grade 2 is where it starts to get interesting, I think, where it starts to get things start to happen meaningfully. And this is a case of, so these sorts of views at grade 2 think that science can tell us things about what's genuinely possible, not merely about what's physically possible, like holding fixed what's generally possible. They think science can tell us about new possibilities that we hadn't recognized before. So we might have thought something was really genuinely completely impossible, not merely ruled out by the laws of physics, but just couldn't happen at all. Not the kind of thing that could possibly happen. And then we do some science and we change our mind. We come to think that this thing that we thought was genuinely impossible actually can happen. Maybe it actually does happen. Usually this happens when we adopt a new theory that kind of talks about something which we previously believed impossible. So we shrug our shoulders and say, well, I guess I was wrong to think that thing was impossible in the first place. But the kind of core to this grade 2 is that science can reveal new possibilities, new genuine metaphysical possibilities that pure rational reflection doesn't reveal. So one example is the possibility of things being like fuzzy at the quantum level, kind of genuinely indeterminate in their properties. That's something that might have been thought just to be impossible by metaphysicians before quantum mechanics came along. And another example is curved spacetime. This is probably the most famous of these examples. Kant famously thought that spacetime necessarily was Euclidean in its geometry. That is, necessarily parallel lines never meet, and that there's no curvature to space and time. And these days we have spacetimes In fact, we use spacetimes in our best series of physics, including general relativity, which do have curved spacetime. So this thing that metaphysicians, including very famously Kant, argued were just completely impossible by their very nature, could not occur. Now we think they not only can occur, but do occur. So this is a case where science has expanded our horizons of what's possible. It's led us to recognize new possibilities where before we did not recognize any such possibility. So here are some pictures of new possibilities where we previously recognized none. And they're kind of a varied bunch, starting with the platypus. All these examples are ones that you can maybe question one way or another, but I hope you'll get the general idea from them. So I'll go through them quite quickly. But the platypus is a creature which was believed to be impossible in the sense that it mixes body parts that look like they come from mammals and they look like they come from birds, the duck bill. And so when specimens were first brought back to Europe by colonial explorers from Australia, the kind of scientific community back in Europe didn't take platypuses seriously. They thought they were faked because it was such an obviously impossible kind of thing, since it combined body parts that just kind of by nature did not belong together. Remember, this was pre-Darwin, pre-evolution. The idea that things had their natural order, and platypuses were just like contrary to the natural order of things, and so it was thought to be so obvious that they couldn't be real. They must be fakes, and it took a long time to convince biologists they were in fact real. Evolution. Aristotle is someone that probably would have thought evolution just completely impossible, contrary to the natures of things, because for Aristotle, as far as Aristotle is concerned, an ape, like a chimp, has a different essence, has a different nature, a different form from a human, and one of those can't change into another. So for an ape, a non-human ape, to evolve into a human is the kind of thing that, if not Aristotle, I'm not an Aristotle scholar, but at least many Aristotelians, I think, would have thought to be contrary to the nature of things and therefore genuinely impossible. Curved space-time is an example I've already talked about, but on that orb, that world sitting in the curved space-time are some continents which are moving. And continental drift is another thing that at certain times has been thought to be just the kind of thing that can't happen. Splitting of atoms below there. The theory was that atoms were the smallest unit. What it was to be an atom was to be the smallest unit. So it was contrary to the nature of atoms for them to be split. It was a surprise when it was found that an atom could be split. At the top right there, those are the brain activity measurements taken from the work done by Benjamin Libet, who is a famous neuroscientist you may have heard of, who argued that we could observe people's free choices before they felt that they'd made them. So these are examples of the activity in the brain correlated with when people reported having decided to make an action. One way of reading this, and I'm not going to defend this, but just the kind of stupid idea to have in mind, one way of reading this is evidence that we can predict free human actions before they're made. If the idea is that the action is made at the point it becomes consciously available for reporting by the agent, but it's clearly predictable that it's going to happen by looking at the graph before that point. Lots of controversy about these examples, but again, the kind of thing that we might have thought human free action rules out. And the moon was previously thought to be the kind of thing that by its very nature one couldn't visit. Maybe it was a god. You can't land on a god. Turns out you can land on the moon. So these are all cases where our view of the nature of something has changed, such that things we thought were genuinely impossible have been found to be possible.
Sorry, Alastair, I actually muted you. I actually misclicked something.
I'm good. I thought maybe I'd gone too far there. So grade 3 is the next level of relevance, and it's kind of in the same spirit as the previous level, except rather than just adding new possibilities, the idea of grade 3 of the involvement of science in metaphysics is that science can tell us which things are impossible, kind of rule out things that we thought were possible as in fact impossible. These are obviously more controversial cases even than the previous lot, but the kind of philosophically the key to this level is that you say that if you find that something kind of can't happen as a matter of its physical nature, like the true physical description of that thing just doesn't permit something to happen, it gives it probability 0 effectively, then this approach says that's not just something that can happen but physics rules out. No, it's something that kind of can't happen at all. If physics tells us it can't happen, we should take that to be evidence that it just can't happen. That's at grade 3. So if we can get evidence from physics or some other science that something really can't happen, that it has kind of objective probability 0, that's evidence, say the philosophers at grade 3, that the thing can't happen at all. And then there are complications to do with properties that aren't actually instantiated in our world, but I'll set those aside because things get distractingly complicated. But the main point is in the examples. So here are some examples. So on the left, we've got an illustration of like electron density in atomic orbitals. Not sure how good an illustration it is, but the idea is that there are places where you just won't find an electron around an atom because destructive interference keeps the probability density suppresses it to 0 there. In the same way, on the top right, that's the like simulated pattern of like particle measurements from a double slit diffraction experiment. There are going to be places on the screen where the probability of a particle impact tends to 0 in the ideal limit. In a messy experimental world, it won't be completely 0, but in principle, there are kind of places where you just won't detect an electron because the probability density is 0 there. Stepping slightly back from quantum mechanics, black holes are a kind of space-time example. You can't if your matter that passes through the event horizon of a black hole, you can't come back. It's not a matter of you could come back if only you could do something you can't. The very nature of what it is to travel through space and time prevents you from coming back. You're not coming out of that black hole reversing course anymore. There's kind of no course for you to reverse. And so that's something that we thought you could do, perhaps, kind of go inside that region of space and then come back out. It turns out that's impossible. And impossible by virtue of the very underlying nature of what it is to be a black hole, what it is to go past the event horizon. I'm going to skip over some of the detailed examples in thermodynamics, but I'll just in case anyone's wondering, that wooden object is a perpetual motion machine, or attempt at building a perpetual motion machine. And it's no surprise to people here that you can't, in fact, build a perpetual motion machine. There's no such thing as a working perpetual motion machine. And that possibility, people at this level of connection of science and metaphysics might say, is something that physics has discovered. You just can't do that. It's the kind of thing that just can't exist. So those two levels were already, I think, kind of substantial and interesting in the sense that science is showing us new possibilities, new genuine possibilities, and ruling out certain things we might have thought were genuine possibilities. So science is in those situations playing a substantial role in telling us which things are possible and which things are impossible. But there's one level further that science might take us in telling us about possibility and impossibility. And this is really my favorite level. This is the idea that science might tell us not just which things are possible and which things are impossible, but it might tell us what possibility and impossibility are. Like what it is for something to be possible or what it is for something to be impossible. And the proposal that I want to kind of present to you in the time remaining is the idea that we can have an account of what possibility, necessity, contingency really are, what it is for something to be possible or necessary or contingent in terms of quantum theory. So quantum theory isn't just a normal physics theory on this view. Quantum theory is in some sense deeper than other physical theories because it's telling us directly about the nature of possibility and necessity and contingency. Whereas, say, electromagnetism only told us about which sorts of things were possible. Quantum mechanics is telling us about what possibility really is. That's the claim. And the way it tells us that, the way that I suggest it can tell us that, is by using many worlds quantum theory and looking at the multiverse, and then looking at variation in the multiverse. So if you have a quantum multiverse, different things will happen in different worlds. Some worlds will contain talks like this. Some worlds will contain no philosophy at all. Some worlds will contain only philosophy by people that want nothing to do with science. In some worlds, all the philosophy will be philosophy of religion. There will be a whole lot of different possibilities in these different worlds of the many worlds of quantum mechanics. And I think we can use those worlds to account for all the possibilities there really are. So that's a view I'm going to describe. And this is the book where you can read more about it if you want. It's called The Nature of Contingency. The subtitle is Quantum Physics as Modal Realism. And like philosophers like to try to sum up the entire claim of the book in the title, and that's what I tried to do there. So modal realism is a doctrine that comes from metaphysics about what possibility and necessity are. It says that to be possible is to occur in some possible world, roughly speaking, where possible worlds are real. So the world we live in is one world. The whole universe is just one world. And there are other ones like this, says modal realism. And they're just as real as this one. They're just not ours. We live in this one, and it's other people that live in the other ones. So to say that this world is actual is just to say that it's the one we're in. The same way to say that planet Earth is here. That's where we are. But it's not like the planet Earth is objectively privileged over the planet Mars. It's just that we happen to be on Earth. So that's what makes the Earth here. In the same way, our world isn't privileged over all the other worlds. It's just the one we happen to be in. That's what makes it actual for us. So that's modal realism. So contingency becomes just a matter of where you are in the multiverse. The same way being now is just a matter of where you are in time, or being here is a matter of where you are in space. But it's not just philosophical modal realism, it's quantum modal realism, because the worlds come from quantum mechanics. They're the worlds of many worlds quantum theory. And so the idea is that what exists are the many worlds of quantum theory. Those are the possibilities, and we're in one of them. And for something to be possible is for it to occur in some other world. Something to be possible but not actual is for it to occur in some other world, but not this one. So I don't have long left, and I'm not going to go through all the details of the ins and outs of the view. You're welcome to ask me about the details. But just to skip through the core points. This view is built on the many worlds interpretation. Goes back to Hugh Everett in the 1950s. And it's a nice approach to quantum mechanics because it's simple. It has a lot of worlds, but it doesn't have a lot of new physics in. It just has ordinary unitary quantum theory and you interpret that as providing you with a multiverse, and then you interpret the kind of specific measurement outcomes you see, not as being the only measurement outcomes there are in reality, but just the ones that occur in your world. So when you have Schrodinger's cat in a superposition, basically instead of one cat in a really weird state, you've got two cats, each in a normal state. So you haven't got weird cats, you've just got more of the normal cats. And for physics reasons, it works well. Its relativistic invariance and locality are kind of built in. It applies straightforwardly to quantum cosmology in a way that quantum theories that need an observer don't apply straightforwardly to quantum cosmology. So the quantum modal realism uses many worlds quantum mechanics, and it says that the different worlds in the multiverse of Everettian quantum mechanics are the different possibilities. And so we can look at possibility at different levels. We can look at possibilities for the way the totality of everything is. And there the answer is there's only one possibility, there's a multiverse. But you look at the level of like what happens around here. And what happens around here is contingent, could have happened differently, just because there are other worlds where it does happen differently. And those are the ways things could have gone. So those other worlds that we're not in constitute the alternative possibilities for us. So at the fundamental level, we have no contingency and the laws are deterministic. But kind of at the effective level, at the level of the perspective that we have on the world, we have effective indeterminism and we have effective contingency. We use counterfactuals, or we can use this account to make sense of counterfactuals. Philosophers love to talk about counterfactuals. These are conditionals, like if things had been different in such and such a way, then they would also have been different in such and such other way. David Lewis's slightly mean example, if kangaroos had no tails, they'd fall over. They wouldn't be able to balance. And the way quantum modal realists interpret this is as talking about some real kangaroos out there in some other parallel quantum world. And they don't have tails and they do fall over, or so says this claim. So, we'd have to go and do some science to find out whether that's true, because science is our best way of finding out what goes on in the multiverse. So on this view, counterfactuals are ultimately about what goes on in other branches of the quantum multiverse. That is to say, they're about ultimately how things are in other worlds. And then for philosophers kind of wondering how the closeness relation on these worlds is going to work, the answer is that you can use chance, I think, to help understand that. So chance is a key part of this picture. You haven't just got a space of worlds in Everettian quantum mechanics. You have a space of worlds with a measure of probability over them. So each world comes equipped with its chance. And what are they chances of in a picture where all the quantum worlds exist? They're the chance of us being in a particular world. They're a chance of this world being ours. So for something to be contingent on this view is, as philosophers say, indexical. So it's a matter of where in the multiverse we are. So it's not contingent what the multiverse is like, but it is contingent where in the multiverse we are. Because there aren't any alternative candidate complete multiverses. There's just one of those. But there are alternative candidate worlds that count as alternative possibilities for us. So all contingency becomes contingency about which world we're in. All uncertainty about contingent matters is uncertainty about which world we're in. So there's a couple of ways to think about this kind of which world am I in picture. So before some measurement happens, before some quantum random event happens, you can think there's one world and then that splits into two. Or you can think there's two worlds all along and they just become different, having been similar before. You can kind of see that these, hopefully these kind of, they match before and then differ afterwards, these branches. And broadly speaking, I think the Everettians should go for the right-hand point of view. That is, they should go for parallel worlds rather than splitting worlds. Here's another picture of that. Instead of one single branching tree structure of worlds, I think we should think of worlds as being kind of separately evolving four-dimensional spacetimes, kind of lined up in a row, so to speak. So the metaphor of parallel worlds rather than the metaphor of splitting worlds. And then which parallel world am I in? That's just the kind of fact to which probabilities attach. So we have a fundamental entity, which is the universal state or the quantum state of the universe, and that evolves deterministically. I'm going to skip over some of the details. These worlds are fuzzy. You have a kind of principle of recombination for the worlds coming out of the Schrödinger equation. You have laws that apply to the whole multiverse. They apply to all worlds in general, and that apply to particular parts of particular worlds. And you can bring these laws to bear on the problem of fine-tuning of the universe, of the initial conditions of the universe. There's a lot of there, and the details are in the book, and I can answer questions happily about them shortly. But just to give another example, a comparison point that some of you might find helpful, hopefully. In some versions of quantum gravity, famously, space-time isn't a fundamental thing.
I'm so sorry, I muted you again. Your mute button.
It's all good. Fundamental reality is not space-temporal. Space and time is an emergent thing. The way fundamental reality isn't colored. Color is an emergent property. Bad example because we talk about quark color, but being hot isn't a fundamental property. And on these views of quantum gravity, nor is being in a particular place or at a particular time. Those aren't fundamental properties either. And in the same way, in Everettian quantum mechanics, being in one possible world rather than another isn't kind of a fundamental fact about the world. The fundamental facts about the world just give you this one universal quantum state. It's only at the non-fundamental level that we get the emergent multiverse, and then we get our individual perspective on that world. So in the same way that quantum gravity is making space-time not fundamental, my approach is making contingency, alternative possibilities, non-fundamental. And the idea that contingency or alternative possibilities might be non-fundamental is pretty hard to get your head around, and it's the kind of thing that philosophers might really metaphysicians of modality are not necessarily going to like. Parmenides maybe said some things that might have been connected 2,500 years ago. Spinoza said a few other things about 400 years ago. But I'm basically done. So what I've been describing really is a new way of understanding possibility, necessity, and contingency, which comes out of quantum theory. So it's a direct result of kind of combining theoretical elements from metaphysics with theoretical elements from quantum theory to get a kind of good overall package of thinking about chance, possibility, necessity, contingency, and in a fully quantitative, precise way. So what we have in this vision is a parallel universe multiverse. The multiverse made of parallel universes with a chance distribution over the whole thing. And contingency, one thing being genuinely an alternative to another thing, becomes entirely quantum in its nature. And you don't have to like that view. I mean, this is it is a bizarre and unusual and in some respects surprising theory of what possibility and necessity and contingency are. But the kind of broader lesson is that it's the kind of thing that you can do if you are imaginative about the ways in which you let physics and metaphysics link up. Don't just try and pursue physics in isolation, metaphysics in isolation, but try to kind of let them mesh together and look for package theories that combine elements of both that might have theoretical virtues that theories just in physics or just in metaphysics can't have by themselves. So I'm thinking of this as a collaborative enterprise. That physics and metaphysics can help each other find these kind of unified package deal theories of these fundamental aspects of reality. Thank you for listening.